Programming Throwdown, episode 127, AI for Code with Eran Yahav. Take it away, Patrick.
Welcome to another episode of exciting, deep programming talk with Programming Throwdown. Jason made me feel a little bit sad the other day. He referenced something that we did like a decade ago related to Programming Throwdown. Then it made me realize, oh, that's really good. We've been doing this podcast a long time. And then I got really sad because I'm like, oh, it means I'm old. So, no, I'm just kidding. I enjoy doing it. Jason, I know it's great. Okay, anyways, that was off topic. So we're here with Eran today. Welcome to the show, Eran. Tell us a little bit about yourself, how you got started in programming.
Yeah, thanks for having me, guys. I think you started by saying you feel old, so I should really keep quiet on that front. I mean, I started programming many years ago. I think my first computer was IBM PC, I think with 5 megabytes hard drive or something like that. That was like the super
That's a lot,
duper...
man. You could never fill that up.
Yeah, exactly right. And dial-up internet and stuff like that. So that has been a long time ago. First programming language was BASIC, if you guys even know what that is. And so it's been a long time since then. I've been doing programming from a young age. I don't even know since when. Did undergraduate at Technion, CS, then did military service, mandatory in Israel for 6 years. What else? PhD, computer science. Went over to the US to do some work on program analysis, program synthesis at IBM Research at the time, TJ Watson Center in New York. And then came back as a faculty at Technion doing machine learning over code, program analysis, program synthesis, all these great things. And during that time, I really got really deep into program synthesis as something that can transform how we write code in reality and not just in academia. And for many years, I've been fascinated by the idea of programs that work on programs, compilers, synthesizers, debuggers. Any program that operates on other programs, I found that like fascinating from a very young age, and this is what I've been doing for a long time.
Awesome. Well, that was a very super. Oh man, I got a lot of questions already. So yeah, so starting in BASIC, I mean, I can relate to that, and then I started in C, and so now that makes me the guy who always has to write the bit shift operations. So yeah, I mean, that's quite a sweeping thing. So you even in our intro were saying that you consider yourself sort of academic, or you're teaching now. You spend a lot of time in university. I know that's similar to Jason. Maybe just a bit before we dig into the other stuff. Like, what are your thoughts for people who are debating, sort of spending extra time in school versus sort of entering the workforce? What are your thoughts about that? We get that question a lot.
Yeah, I think I'm quite biased. Probably, I think that going to school is great. It really opens your mind and gives you a lot of taste and kind of experience and things that you would never experience in the workforce, right? Like in a daily job, just because the incentives and the objectives are very different. So I spent 4 years in undergrad. I think today many programs only require 3 years. And I think that fourth year in which I did like courses in networks and AI and whatever natural language processing and things that I would never like even know that these topics exist, let alone like go into the depth that you can go in undergrad if I only met them while doing working at a company. It's just impossible to get this kind of like wide perspective, and I highly recommend for anyone to just spend this extra year or extra couple of years getting exposed to things, because this really changes the way you think about problems. It happens to me very frequently that I like bump into some problems and say, but wait, that was something that I actually met in computational biology. There was an algorithm like that in computational biology. And even if I don't remember the details, I kind of have the pointer in my head and I can go and look for it and kind of refresh my knowledge about it. So I think that has been like building this kind of reference in your head of all the topics early when you're young and things are really big, it's easy to get them like recorded at like the infrastructure level of your brain. I think that's super helpful, and it's an investment that is really pays itself back very quickly.
Nice. Yeah. Thanks for that input. I mean, I think that's something that people debate. I'm not sure there's a right answer, and I think it varies person to person. But I mean, I think that's really good, observations. And you said something which I think a lot about, and I know Jason does too, which is this word incentives. And I think it's really interesting to view a lot of things. I don't want to say in life, that sounds too deep, but like a lot of things, at least in interacting with people at work and thinking about incentives. For me, that's been something that it helps explain a lot. And so as you point out, when you're in school, I think your incentives are very different than when you're in the workplace. And I think, like you said, the experiences you'll have, even just thinking in that lens, you can sort of understand how they may be starkly different.
I think it's important to understand that every endeavor at the end is human endeavor, right? So research is, and the workplace is, and people, are at the end motivated by, even if the incentives or the kind of target functions are very implicit, they are there. And in the workplace, you're supposed to get something done at the end, right?
A kind way of saying humans are greedy, yes. And
No, it's not greedy. I think it's not greedy. It's natural, right?
that's true. Greedy ascribes some sort of moral aspect to it, I
Yeah,
guess.
exactly.
All right. So, we talked about in Jason's intro, he said that this episode's going to be AI for code. So, I mean, I think talking about how code development works, and even in your sort of like introduction talk, you talked about synthesis, analysis, programming. So back when I was first writing QBasic and, sort of inputting that and like line 10, go to, 10, whatever. Oh, I wrote an infinite. Okay. Anyways, it was just an editor. The editor was very simple. I don't even recall it having syntax highlighting. That was sort of it may have had, I can't remember now. It's been too long. Those early days, and we're starting to drop some of those words. So everyone kind of, I think, understands. You open VI, Emacs, Notepad.exe, just depending on your platform, and you start putting like things that represent a program as text into that sheet, and that's sort of everywhere starts. And then sort of take us on how you think about, I think there's a lot more than this than just editing the code, but maybe starting there, like for me at least, well, maybe it starts before in how you think about what you want to put on the paper, as it were, or we want to put down. But maybe take us through a little bit like how you think about those early days and how it was approached, so that we can sort of set up how it's sort of undergoing some amount of transformation.
Yeah, I think it's all a question of balance between the human and the machine, in a sense. In the early days, you had to work really hard to satisfy the requirements of the machine. And the machine was kind of brutally unforgiving, right? Like you could make one single mistake. Nothing told you that you made that mistake, and the whole thing would go awry when you run it, right? And so over the years, people had this brilliant idea. I think Fortran was the first, that you can use the machine to help the human deal with the machine, which is, I think, the idea behind the compiler. The
Okay.
early
Yeah.
compiler is exactly that, like help the human write something that is slightly higher level. The compiler will do some work to check it and maybe give you some useful errors, and then the machine would run it for you. And so this is kind of like really the early idea of having a machine help the human program it and making it more forgiving in a sense.
Yeah, I was right there. So maybe people don't realize or know. I mean, I wasn't exposed to it initially and then found out kind of later. But so originally people would write literally the hex codes for assembly to like, basically script the exact flipping of the gates inside the microprocessor. Oh, this is my background. I'll get here all day. So I'm not going to talk about this. But like, actually writing hex that is stored in an EEPROM or whatever, and the CPU actually executes was like step zero. The very first people who had nothing else, I guess that's what you kind of got to do, right? Then people realize, oh, hey, hang on, we can use, I believe the word is mnemonics, right? Like I can say hex code, this is actually the word MOV, move, right? And why it wasn't longer, yeah, ask someone else. But like MOV branch if equal B and E, branch not equal, right? Like all these stuff, and moving the registers and still thinking about the physicality of the compiler. Then the very early thing was like a 2-pass assembler, right? So like I could use labels. So I could use a label for a line number or an address and use something else. And the compiler would scan through once, pick up all your labels, figure out where they go, and then scan through again. But that's super, super low level. And so what you're talking about, Fortran, this idea that like you don't need to write like one-to-one assembly instructions was like, yeah, I think I agree, like a very early breakthrough in how to get the machine to do the work that you really didn't need to be doing.
Yeah, I think since then, I think there's been a lot more kind of development in how the machine can help you. You mentioned syntax highlighting earlier, but also all sorts of more sophisticated compilers that can give you really deep error messages on what you did wrong, and also linters and static analysis that can point out common errors and maybe even suggest corrections. And all these things that make our lives easier. But at the very end, programming is still extremely unforgiving, right? If you compare it to having a conversation in natural language, it is still like you can spend the whole day, like flipping because you flipped two parameters to a function or just forgot the semicolon somewhere, right? And this is like extremely unforgiving, even today. And it's been a while since Fortran. Yeah.
Oh, that's true. Okay, so I think people probably know like what syntax highlighting is, and if they've had any experience, they probably kind of get that. So static analysis, though, maybe can you explain like what static analysis is?
Yeah, in essence, it's really kind of like an expansion of the compiler to check properties that are more than maybe just type checking or the standard things that the compiler checks, to more sophisticated things, maybe properties like your program does not divide by zero, or you don't have a null dereference, or no overflow, and properties of that nature, and all the way to like full program verification, which is checking that your program satisfies kind of a functional logical specification, that a given function that is supposed to sort an array actually returns an array that is sorted, and check that statically, meaning without running the program. Right. So the static part here means that I'm not going to run the program. I'm going to statically check it at compile time and give it the result. And now some of the listeners may like scratch their head and say like, but wait, this sounds like something that is undecidable, because if they've heard about kind of the halting problems, they like, wait, can you check that the program terminates? Probably you cannot. And so indeed the problem is undecidable, but you can solve approximations of this problem. And typically the way that static analysis works is that it gives you conservative errors or conservative reports, meaning that if it says that there is no error, then it's guaranteed to be correct. But it may give you false alarms saying, hey, your program may divide by zero, which actually doesn't. And so that has been quite useful at the end, but it is also often quite frustrating for developers because they chase down all sorts of reports that turn out to be false alarms, and that can be really frustrating. But yeah.
So I think like, yeah, I mean, so I've run static analysis before, and I mean, I think the compiler does, some form of static analysis, and even now like the better, but like separate tools often, go in more depth. And this frustration you're expressing is was sort of my experience, that you get a lot of stuff where it sort of just gets confused, which already we're sort of talking about the computer doing more and talking about getting confused or not understanding. And we're talking somewhat about like humans have some intent when they write their code, but then how they express it may not match. And then something else is trying to like understand it. So when we say like the computer tries to understand what you're trying to do or tries to check for a divide by zero, like what are we actually meaning there?
So yeah, without like getting all academic here, I think the right view is that the static analyzer, or the machine, let's call it, is constructing some abstraction of your program that it can reason about. and that abstraction does not always match your idea of what the program does. And this is where the kind of the confusion or the mismatch comes from, and is also the reason that sometimes or often these tools cannot explain why they got what they got, right? Or not in a way that you would understand it, not in a way that would be useful for the human. So the chain of reasoning that led them to the conclusion that you are kind of amazed by or shocked by is not easily explainable to human. But you're spot on in the point of kind of understanding the intent and communicating intent to the machine, and all these questions are really central both for program analysis and program synthesis. How do you know what is it that the human was trying to do?
I mean, I think like when I tried to explain to people who aren't in programming, like what debugging or what these things are like, I just get blank stares. But I mean, for people who have programmed a lot, I think a lot of people experience that where you write some code, you have some intent, you run it, and even it turns out that actually the computer got it right and you got it wrong. That you thought, a number, you coded better than you like solved your own problem. And I think for me, the interesting thing about static analysis or even just compilers adding that to their repertoire over the years is like the number of things you can hold in your head at one time. So the interaction between functions and that oh hey, you're calling this thing over here and it has this or that, and did it really is well, I come from a C++ background, so like for me it'd be like, can this function ever return a null pointer? Well, if it's simple enough, maybe it can never return a null pointer unless a null pointer was provided into it. You can kind of start keeping track of all of those things. And we know a computer is really great at doing repetitive things very quickly. And so holding all of those simple functions in its head, it can do those sort of bounds checking, like what is the biggest number that this could get? Is it an overflow or underflow? And even if it can't tell you you're right or wrong, what I've seen be useful is that sort of cooperation where it sort of comes back and tells you like, hey, based on what I see here right now, like this is the range of values you can sort of expect out of this. And that's when you sort of start to see, oh, wait, there's actually this like iterative thing where I'm doing something, the computer's telling me what it thinks I meant to do, I'm telling it back, and you sort of do this. Happens to me, I guess, more now as like the error messages are getting better and whatever, versus when I first started out, what I would find myself doing is writing, enormous blocks of code and, trying to run the program as a whole and just see if the right thing comes out at the end.
Yeah, absolutely. So that's exactly the progress that we're seeing, this tight loop between the human and the machine, that the human is doing something, the machine is like giving you feedback. And now essentially, over the years, we are getting closer and closer to working together with the machine when you write the program. What you described effectively is kind of like the iterative discovery of the specification, right? When you start programming, you have kind of a loose idea of what it should do, but you don't have all kind of the edge cases and all the subtleties, because you start with high level thought of high level spec. And as you write the code, you start to discover and unravel kind of the low level details and the hidden complexity that is in there. And what you described is the machine kind of helping you unravel that as you make that progress. And I think this is also where synthesis comes in, which is the idea that if you express your intent clearly enough, the machine can actually predict what is it that you are trying to do from your intent and from context, and complete the code or complete the thought for you in a way that also kind of prevents you from falling into the standard or like the common pitfalls around that area.
Yeah, that makes sense. I think one of the things that is really, I think, where program synthesis becomes important is in figuring out all of the assumptions that matter and the ones that don't. Like for example, you might have a function that just takes a number and increments it. And then some static analysis tool says, "Oh, but you could have passed in the biggest possible integer ever and now your program will not work or will overflow." And it's like, okay, yes, that could have happened, but no, like it's not useful, right? And so it becomes, as you said, this symbiotic thing. And so I think one of the big challenges is how to know what sort of errors are useful for people. That seems to be kind of where all the magic has to happen.
Right. And I think this is exactly why I got excited by program synthesis as opposed to kind of the static analysis tools. So I've worked for, I don't know, many years on static analysis tools. And really, as you said, the symbiotic thing with static analysis tools is quite tricky because you have this thing that is always complaining, right? And complaining about things that are kind of like, hey, I don't care about that. That's not the problem here at all. And so it actually ends up distracting you more than helping you. So it's a symbiotic thing, but there's like this nitpicker that is like complaining about the immaterial stuff and distracting me from my actual thing and breaking my train of thought, right? And this is why I think that's the challenge with negative tools that complain all the time. And this is why I find program synthesis so compelling, because it says, hey, Eran, I see what you're doing. This may be really helpful for you, like this piece of information or this next line of code. And I say, you know what? I don't care. Let me keep on typing. I'm like, I'm on a roll, so I'll keep on typing. I won't even notice. But if I'm like stuck for this extra fraction of a second, and I look at the suggestion of the tool and says, oh, yeah, that's exactly what I wanted. Thank you, dear program synthesis. And I can consume this and keep on going. So rather than complaining, it is suggesting things. And I think maybe the simplest analogy is kind of like assume that instead of type ahead on your phone, you had just a spell checker that complains all the time when you make the typing mistakes, right? And so type ahead is infinitely more useful, right?
Yeah, I mean, I think like to take like a very specific example, I guess. So Jason's thing, like I just write a function called increment or +1, and the thing is complaining, squiggling lines everywhere, being like potential overflow, like no bounds checking, whatever. Like you're right, that's really annoying. And I guess there's like as programmers progress, or even like their understanding of it, what they want to do. As Jason pointed out, I'm gonna be like, yeah, that's not really practical. I don't really care. But on the flip side, I know that is a risk. And if we start talking about like how components get reused in ways that didn't get expected, if the tool that I'm using says, hey, actually let me add in the bounds check for you, then unless it's performance critical, again, my background, like I'll probably let it do it, right? Like, oh, if equal to int max, just do nothing. Like, okay, well, at least it didn't increment, but at least it doesn't overflow and give me a number smaller than what I put in. So I can at least say that now I know this function never shrinks and only grows, but maybe is equal in some small case. And so having this synthesis, like you say, is actually in some ways applying it useful, more complicated, because you first need to understand there's a problem and understand like an acceptable solution, that like, hey, an acceptable solution here is to bounds check and do nothing, to bounds check and throw an exception, and what framework I'm in, what language I'm in. I guess like that could vary wildly.
Yeah, in a sense, it is kind of more complex, but it's also more in your flow, right? So abstractly, you're correct that I need to understand more, but I need to act less in a sense. I need to look at it and say, yeah, I don't care about this. And like, whereas with the static thing, I'll have to work for the tool to satisfy it, right? Because I'll have to like ignore bounds check on the thing, or I'll have to do something actively to make this thing stop complaining. And I think that is the frustration that a lot of people have around that. I think synthesis is kind of like the cure for a lot of these things.
Do you find like, when you talk about static analysis or synthesis, I mean, like some languages aren't used so heavily anymore, so maybe excluding those, but of languages that people would encounter every day, do you find that like people's acceptance of those kinds of tools varies based on like the kind of language they're using or the kind of development they're doing? Or are people generally like pretty open to like, having the computer help them out more?
Yeah, I think people are very open. I think there's kind of like the bottom 5% of developers know the really, really new ones who don't know what's going on are going to get really confused by synthesis tools, or potentially confused because they're getting these suggestions and they don't know what is it that they're getting and why. So it's kind of like it's going to be tricky. and the top like 1% of developers who are doing like device driver development, one-off thing, algorithmic, this or that, the suggestions are not going to be probably on target because their intent is so kind of one-off and complicated that this doesn't match any of kind of like the common distributions of how people write code, right? So either they would need some specialized model for device driver development, which is kind of like almost its own language, right? It's like its own set of
Right.
idioms, or they would rather not use any tools because also, they work in VI and all the stereotypes around that, right? So
Yeah, I mean, I think like we've had those editor debates before. I think even on this show we've talked about it, and I think people change over time. And I think you can get lots of tools to do lots of things depending on how much you're willing to sort of spend on it. But for me, the realization that I've had of where I am now, at least, is this computer cooperation, which is again that the computer, just as simple as, hey, there's this function. Where is this function coming from? And sometimes it actually turns out it wasn't the function I thought it was. It's pulling it from somewhere else. And having used various tools, sometimes that is a guess based on code match, and sometimes it's based on actually understanding how it's being built. And this is leading me. I am going somewhere, and that is that across the different platforms, different code bases, different frameworks, there's a lot of difference. How does the tooling sort of like, we said builds an abstraction, but is it like just like operationally, how does that work? If we have programs in C++, Java, Python, like is that intermediate common enough to be useful and reasoned about, across all of them? And it's, front ends and back ends into and out of those things? Or do we need sort of like some understanding that differs, like you were saying for device driver, you might need something just entirely different. How like common or unique are each of those scenarios?
So it becomes, it's hard to discuss this in the abstract. So I think
Okay.
we need to
Sorry.
concretize it
Sure.
a bit more. So most of the synthesis tools, or let's say the AI for code tools, do have some semantic aspects that are language specific. They have some, let's call it, extraction procedure that extracts some representation, interpreted representation from the language, which includes information about maybe types, maybe how data flows between variables, maybe some other things, which is quite language specific, and they extract it to a common presentation, much like a compiler does before it generates code for the backend. So for people who don't know, like, GCC or something like that, standard compilers, they may have a lot of front ends and a lot of backends, but they communicate by extracting or by first translating the front end language or the source language into some interpreted presentation, and the backend works off that. So similar to that model, static analysis tool or program synthesis tools also have typically front ends that extract some semantic information to an interpreted presentation, and then the entire back end works off that. So yeah, there are some language specific, let's call them features, but most of the machinery is language agnostic.
I see. So I know also I don't know too much about GCC other than it's GCC. So we'll talk. We can talk about Clang, and then I maybe like to contrast it with like JVM or Python. So for many languages that can be compiled by Clang, Clang has this IR, this intermediate representation, and it's actually a very powerful thing because anything you can get into the intermediate representation, you can get machine code out for any backend that Clang supports. So PowerPC, x86, ARM, whatever your specific. And if you want to write a new, host system, it's just as simple as, writing another one of these backends. And then optimizations can take place in this intermediate represent. Okay. So Java has something, I guess, a bit similar, right? You compile to this sort of the bytecode, and other machines can target to that bytecode. I don't know what it is for Python, but once they're in these representations and we're sort of at that intermediate, how similar are like the programming constructs in I've never really thought about it, like in Python versus, Java versus sort of like what would have come out of C++.
Yeah, I don't think they're necessarily very similar at that level, but kind of the concepts of dynamic binding or all these kind of like fundamental program language concepts are there. The modeling can be quite involved. For example, if you've ever looked at how Scala is compiled to the JVM, if you had the kind of, I guess, maybe misfortune of looking into these details.
Nope.
This is extremely involved. It's really beautiful conceptual and engineering work by the Scala team. It's really amazing, but it's really complicated.
Sure, sure. Okay. So yeah, so when we have these static analysis tools and synthesis tools and we have them per, kind of thing someone is doing, I mean, I guess we can sort of like keep moving up the stack. So you have your code base, right? So I have my code base, and how my code base behaves may be very different than Jason's code base. We do entirely different kinds of programming. So how do these tools sort of balance the like you sort of said, the meat of the distribution, the sort of like average case versus the tailored case of, hey, on this project we've made these, I don't want to say artistic, these opinion based choices, like how does the tooling sort of balance between those?
Right. So typically the tools build some universal model, and that universal model captures how code behaves in the, let's call the common case, in the wild. Let's say I look at all the C++ projects on GitHub, and I will get some abstraction of what these projects do, how they're supposed to behave. I'll get some distribution of, the expected code completions or code predictions that I need to do for these projects. They would work quite well for the majority of new C++ projects. But if you have made your own opinionated kind of decisions that are veering off significantly from, let's call it, general population, Gen Pop, then you would benefit greatly from training a custom model for your project or your organization to kind of capture these notions, right? And so the bigger your code base is, effectively, the more you would benefit from having your own private model. It will better capture like how you do things, right? How your team
Sure. Yeah, yeah.
is doing stuff.
So then, I mean, I guess you're starting to veer obviously where we're going, but the static analysis, code completion, I mean, doesn't have to always be done by a trained system, right? I assume
Yeah.
that prior these were things that were hand done. So hand modeling, hand feature extraction, hand suggestion and tuning, and then,
Yeah, that's exactly right. So maybe there's like kind of a pause that we need to make here and kind of distinguish, I guess. I don't know if it's the second, third, or fourth wave, so I'll not put a number on kind of like which wave is it of the static analysis tools, but let's call it the previous wave of static
sure.
analysis tools. Uses like hand-coded rules that say, oh, if you call foo and then you call bar, then this is really a bad idea. Like
Mm,
if you check whatever in Java, if you say if x equals null and then the next line says x dot foo, then this is not a good thing, right? Because you're likely to get a null reference. And so these are like hard-coded rules that capture the common case. They're manually crafted rules. And this is how like linters like ESLint work, right? They have like, I wanted to use like the S word, but they have a bunch of a bunch load of rules that were written over the years that capture a lot of like common anti-patterns. And these may not be the anti-patterns for you and your project. And this is why you get a ton of kind of complaints from these tools that because they're capturing generic things. That was like the previous generation of tools. The new generation of tools is using AI to learn kind of what is it that is being done in your code base, what are the patterns, what are the anti-patterns, what are things that should be avoided, and is actually using that information to give you much more targeted kind of alarms and reports on your code in case of checking, and also much better predictions of what code should be written or how to complete your code when you're doing the program synthesis. Right? So this is kind of like the difference between handcrafted things and learned things. And the reason that we can learn all these rich information about your project or about code in the universe is because of the progress that has been made in recent years in static analysis technology, in machine learning algorithms and models, and also in the computational power. So we're just, we can throw huge GPUs and memory and data sets at the problem and kind of train models that are able to capture information or rules that would otherwise have to be handwritten by experts.
So when you're writing these handwritten rules, you're saying, this set of operations can cause, like we talked about before, overflow or underflow or undetermined behavior. Or it's my opinion that if you return a value, you should always use that value. And so like I say, that's a rule, right?
Yeah.
So some set of experts deems, sort of what is good or bad. What are the, when you analyze code bases and, sort of try to apply machine learning, in my head, I'm trying to think like, how do you get those sort of quality metrics? I mean, that the code compiles is insufficient.
Yeah.
That the code runs is, I mean, maybe that's how that seems a bit tricky.
Yeah, I think that the crux of the matter is specifications at the end, right? Like the reason that I say a value that is being returned should be assigned somewhere. This is a specification, that's a property, and that property is probably kind of like a hygiene condition, right? It's something that is good to have regardless of what your program is doing. So that's kind of like a generic universal specification that should hold anywhere, allegedly. Right? And this is why we check it. And I don't know how to check for your program that, a student class should always have the ID field assigned. Because, as a general rule, I don't know what is a student. I don't know what is an ID. And I don't know even how to express this as a general rule. And I'm definitely not going to put it in the list of rules of ESLint to check across the universe, because most of the universe does not have the class student and a field called ID. So this kind of like specialized specifications for your project, for your setting, are exactly what the machine learning algorithms can pick up and check for consistency of, right? And more importantly, with program synthesis, they can generate the right assignments to make sure that as you're doing these things, you always assign the ID of the student, right? They can make sure by construction that you're using these classes or using these pieces of code the way they were intended.
Today's sponsor is Rollbar. Rollbar is the leading platform that enables developers to proactively discover and resolve issues in their code, allowing them to work on continuous code improvement throughout the software development lifecycle. Rollbar has plans for all situations, from free to large enterprise. With Rollbar, developers deploy better software faster and can quickly recover from critical errors as they happen. We have a special URL at https://try.rollbar.com/pt for Programming Throwdown. There you can find 2 free ebooks, How Debugging is Changing and How Dev Experience Matters, as well as sign up for a free trial of Rollbar. Yeah, so maybe to I'll use Jason's term I like here, double click on that for a second. We go into this that, okay, so I've seen this, on Hacker News or Reddit or whatever, someone trains a hidden Markov model over a code base, and I can generate something that on first pass looks like code, right? So, and to kind of unpack that a bit, it's not my field, but what I understand about that is I can generate new code which matches the pattern or statistics of your code base, right? So whenever you call this function, insert new student into database, everywhere in the code base you do that on the left-hand side, you always, say Boolean successful equals, this function. And I can tell you when I emit this code, I always put Boolean but I don't know why you do that or why in, this other case. And if it's split 50-50, then, the generation will 50% of the time do it, 50% not, right? Like I can match this. So I think people probably have used tools where they've seen that pattern matching or, hey, other places in this file, you always followed this word with that word. I mean, I've used those tools before. I didn't find them that useful. So what is the, objective when you're doing this training of these models that differs from just sort of matching the statistics and actually sort of doing what I think you were kind of alluding to, like the right thing?
Yeah, so I think it's kind of the difference between a bicycle and a spaceship. At the essence, they're kind of like, doing the same thing. They're vehicles, they're moving stuff, but one is just like insanely more powerful than the other. And really, it becomes to a question of how powerful are these models in the ability to tailor the context in which you make the prediction and generalize over that. And so we're kind of, these days, we're using models with hundreds of millions or billions of parameters, neural networks with billions of parameters to solve kind of this exact predictive question of here's like the context that I have in my editor and what is it that I should be typing next. And this model contextualizes not only on the last 5 words that you wrote, which is like hopelessly naive. They contextualize on the entire context that you have in the file, including natural language, including other peripheral information from the project, including all sorts of other signals that you have in your environment in order to make a prediction. And this is kind of being able to contextualize and generalize over that is the magic that gives you really accurate predictions that people appreciate and can use, as opposed to just I flip a coin and I suggest that the next word should be either foo or bar, right? Or like, yeah, you did like db and I guess either the next word is add or remove, right? It's like, and so it's much more, the models are just like much more powerful than that.
So I guess like, again, like for people who may not be aware, I mean, is it that you have a sort of hybrid system where you're trying to actually sort of like imbue some human architecture to these models, or are you sort of just setting up the problem and allowing sort of an end-to-end solution to become trained?
Yeah, so like in reality, all these systems are not really end to end just because of kind of the engineering cost of doing the inference end to end is typically prohibitive, and you need to do a combination of several models in order to get the response on time. And then there's some bias using semantic information. And again, there are a ton of details that I'm not sure that this is useful to discuss here. But yeah, ideally, you would like to have it completely end to end, but it's in the world of practical engineering, you need to do something more sophisticated than that.
Yeah, that makes sense.
Again, we're working in the realm of like near real-time synthesis, right? You're typing stuff and you have to generate these predictions of what comes next in near real time to be useful. And this is where the engineering gets really clever.
That's what I was going to say. So, I mean, I guess it's one thing to be given an infinite amount of time to make a suggestion versus I'm going to be typing it and you have to beat me to it or it's not useful. And so, as you mentioned, I can imagine the amount of engineering that goes in from, oh, hey, I read an academic paper that says, we can, suggest code completion at an, X% accuracy to actually being able to deliver that in an IDE. So, maybe to talk about that a minute. So, I mean, you guys have built a system to do some of this. This is, why you've thought about this so much and, trying to integrate it. At an architectural level, how does that end up working? So, I'm typing in my editor and, words are appearing on screen. What's happening sort of in the background to end up giving these suggestions?
Yeah, in the background, there's kind of, I guess, 500,000 lines of Rust code that are running under the hood and doing very efficient neural network inference that involves between 2 and 4 different models that are being kind of combined together and have different trade-offs in terms of response time and accuracy. And if you're typing slightly slower, engineer may catch up and you may get slightly better predictions because the stronger model kind of made it in time. And if not, you may be getting results from a slightly inferior model. And it's really the challenge really for a lot of it is actually the balance between the human and the machine. How do you make predictions at the right places that do not interrupt the human? Right? We're kind of obsessed on these exact kind of finding the balance of when to make predictions, what kind of predictions to make, where, what should be the confidence from the model before we throw it in your face, what other kind of barriers are there before you interrupt the human, and how do you get into the flow of the human in a natural way such that really the human is kind of can easily ignore it if it's not helpful, but actually consume it if it is helpful, right? And there's a lot around that. So
Yeah, to pick like maybe just even an example there, like how does that in practice do you guys approach that problem? Like one example I can think of is how much code to suggest. So
right.
I could complete your line, I could suggest your function, I could suggest your whole no, I mean, we can't probably program yet. Maybe we get there in a minute. But like, how do you guys sort of balance off like trying to figure out how much to end up sending up onto the screen?
Right. So luckily, we've been doing this for a while, and we've been serving millions of users. So we actually run some experiments in the wild to find out like what kind of prediction horizon is most useful for people. And it also depends on kind of the intended. Again, it depends on context, but let me put that aside for a second. It turns out that what humans like the most is pieces of code that they can make snap judgment about the correctness of. So the kind of the tight loop that works best is the human writes something, or there's sufficient context. The human writes something, and the machine suggests something that is easily identifiable as useful. So, like kind of, let's say, complete to the end of the line, but something that is very idiomatic. So, if you see it, you will know that, yeah, that's what I meant, right? So, this is kind of what we call internally the remind me model, right? It's kind of code that I've written it 1,000 of times. I know what I'm going to write. If I ask a human next to me, they know what I'm going to write. Right? Like my classical example for that is read the Python file line by line. That's like a code I wrote, I don't know how many times in my life, probably thousands of times in my life, right? And if I see it, I know that it's correct. I don't need to kind of ruminate about it. It's like, yeah, that's it. And so that's kind of the classic case in which I can complete more than one line because it's really idiomatic. When you see it, you know it's that, it's what you need. It's kind of code that otherwise you would copy from Stack Overflow, right? That's kind of the idiomatic thing to think about it, right?
And so all of this is happening sort of local on the developer's machine. And then like how does that split happen? Like obviously some stuff probably needs to happen in a sort of server somewhere.
Yeah, so what we do technically, what we do in Tabnine is we allow you to configure the architecture or the kind of configuration that you'd like to run in. You can run everything completely locally, even air gapped, so you can run it without network at all, or you can run some of the inference on the cloud, which obviously gives you better completions because you run with stronger GPUs than what you would otherwise have CPU only inference on your machine. Or you can run completely on Tabnine Cloud, and you control, or you can create your own server in your organization and run it. So you can control which kind of models are being deployed and where do you want to deploy them. I think that's really useful for developers to be able to control where inference happens, especially because inference does require some context from your IDE, right? So you may be quite sensitive to where this stuff is being sent, depending on mostly on policy of your workplace.
Yeah, that can vary wildly. So before we dive into like, talking about Tab 9 specifically, sort of my last comment here is you mentioned trying to maybe come up with how many waves and you refuse to give a number, which is fine. But then like going forward, I mean, what do you sort of see the future? I mean, since I was in school, everyone always said, oh, maybe one day we'll just, tell the computer what we want and it'll just, write the program for us. And people scoff at that. And, maybe that's not exactly the future that shaped up. But I mean, and it's fine that this probably gets highly into opinion, but
Yeah.
if we sort of look maybe enough out sort of 10 years, 20 years, what do you think will be the direction we sort of head in for how developers interact with their code?
So I think first of all, it is pretty safe to say that 2 or 3 years down the line, all code will be touched by AI in one way or another. Either it will be generated by AI in parts, or it will be reviewed by AI, or tests will be generated by AI. Something will be done by AI to automate the mundane parts of the job, right? There are so many repetitive work being done, and a lot of it really can be and should be automated by existing AI machinery. And I believe that this is already happening and is going to accelerate as these tools become more mainstream. So I think that's like an easy prediction to make, and I hold it very strongly. Looking 10 years down the line, this is really like speculation and opinion. I think in specific domains, it is going to be the case that you're going to see a lot of automation. Like if what you're doing is writing components for UI of a particular area. I don't know, UI for medical devices, right? It has to be very
Sure.
specific, and
Yeah,
there
yeah,
is
yeah.
and the reason that it has to be then a lot can be automated from intent. The reason that it has to be specific or domain specific is because, again, it's all a question of intent. How do I express as a human the intent to the machine? And this intent is always going to be very partial, right? Otherwise, I'm going to have to write a lot of English prose to express what is it that I want. And this English prose is going to be ambiguous. And this English prose is going to be harder to debug than actual code. So I don't believe that in general purpose programming is ever going to be replaced by English. That sounds preposterous to me. Maybe I'm wrong. But in domain specific things, I think we're going to see like a lot more automation, but it's not going to be, I conjecture that's going to be more along the kind of low code, no code idioms that,
Yeah, yeah.
like if it's similar to Wix in a sense, doing website, right? If you're doing website
Sure.
design,
Yeah, yeah.
you can get a lot done without writing a single line of code. But this is kind of domain specific system that can assume sensible defaults when you don't provide them, right? And so you can provide zero information almost to Wix, and it will do something sensible because the defaults have been baked into the system. And this is going to pop up more and more for more domains are going to be automated, I think, in that flavor. And for general purpose programming, which is always going to be around, right? I don't think anyone should be worried about their job. Uh, the job is so much about specification discovery and not about specification implementation. It's not like no developer gets like 5 pages of English descriptions of the function and then goes to implement it, right? They get a higher level specification, and what they actually do is like carve out the real specification with all the details from it. And programming is about specification discovery, really. It's not about translating English to code.
Just to riff on like what you're saying, I mean, I think we have to get there. And the reason why is because something I've noticed happening and it makes sense is when we say programmer, I mean, we tend to think about, someone at a, what do they call it? I always forget what the latest acronym is, but like a Silicon Valley company or a startup or whatever. But in practice, there are way more people writing code outside of those areas than and then inside. And I think that's going to continue to grow as software permeates just everything. I was talking to a gentleman just like a few days ago, and he was saying, "Oh, I have this idea, but like, I don't know how to find programmers and blah, blah." And I'm just thinking like, yeah, like, I mean, what you're saying sounds cool, but like, you're going to have to convince somebody who can be paid a lot more to do something a lot more worthwhile. And that's not to say your idea isn't. It's just like, I know I didn't say that to him, right? But like, it's not that your idea is bad. It's just like, you're not, it's so niche that like the return there is just never going to be big enough to pay, someone what, they can do, at one of these other, uh, larger addressable market companies. And so I think as you look across just every company needing, some amount of programs to be written and software to be developed, we have to figure out collectively, or I guess someone figuring out collectively how to like empower people to do program writing at the level that can be trained more easily rather than requiring this, sort of academic background. You called it sort of general purpose program. I think it's a fair term for it. Being able to fully debug something, write completely custom greenfield code, this kind of stuff, but instead just turn out another version of something and make small tweaks. And, people in mom and pop shops are going to have to be able to do that. And something like you're saying is a way that happens. I don't know it's the way it happens, but it's a way we sort of get this stratification where programming becomes a much more diffuse term all the way from this sort of low code, no code down to the people, optimizing assembly inner loops for, microsecond improvements on, frame rates of AAA video game titles.
I think there's another trend that will for sure become stronger, which is making programming more forgiving in general. Like I write a program, it should run and do something. And we've made huge progress moving from C, C++ to like Python, JavaScript, right? The barrier to get hello world, right? The time to hello world has shrunk considerably moving to these languages. And I think we're going to see more of that by the environment making also some sensible assumptions. If what you're doing is writing like, some website using Vue, React, whatever is the cool, latest cool thing to write website front ends, then there are sensible defaults that could be made, simplifying a lot of the grunt work that has to be done right now. I think this is another trend that will continue to grow with the assistance of AI, because you do need some sort of intelligence to figure out how to deal with the complexities there.
Yeah, one thing I've seen that's been really cool is, I mean, I saw this first with Wolfram Alpha, and now there are some startups doing it, but basically ways to query knowledge stores, like query databases, and you're seeing things like, give me the average revenue for all the people in Switzerland, all the customers in Switzerland, and just from that English sentence. So that's, as you said, that's something very domain specific. If you just have an arbitrary database called foo and all the columns are called bar and baz, like they can't do anything, but it can pull out unique things like, oh, this column is called country, and I just know when people make a column called country, I can assume what they're going to do. And so yeah, you're starting to see this with databases and those queries, and I think it's just a matter of time before it gets to code as well.
Yeah, you're starting to see it, but it's always super subtle. And from what I've seen, at least, you write this in English and then say, but wait, when I said Switzerland, what exactly did I mean? Did I mean like also the part of Italy that is, working in Switzerland, or only Swiss citizens,
Oh,
or
interesting.
what exactly? It's like you become in all these subtleties that is exactly the job of the developer to kind of like go back and say, but wait, there's actually a question here. Is it the citizens of the country, or people who work in the country, or what exactly is the definition of these terms that you're using, right? And this is exactly where the programming language doesn't let you be ambiguous.
Yeah, that makes sense. And this gets back to your code synthesis. It's like, well, I've seen 10,000 people ask the same question, and 9,900 of them had these assumptions. So we can use statistics to just give people a prototype, and then they'll still have to look at it, but we'll get it right so often that it's super useful. It's like Alexa. Alexa. My parents have like a thick Italian accent, And so Alexa gets maybe 90% of what they say right now, which is amazing. It used to be 0%, but at some point it climbed up, and it got even before it hit 90%, it got to the point where it became useful. Like there was a crossover point to where they could just tell Alexa, set a timer, or set the timer, or whatever. I did terrible mom accent. Sorry, mom. But they do, like, set a timer or something like that, and it's correct enough that they, when it's wrong, they just to try again or use their phone or something, and it's still a net positive productivity.
Yeah.
Cool. Well, let's talk about Tabnine for a minute. So, tell us a bit about what it's like to work at Tabnine. Are you guys currently like wholly remote? I mean, the world's a crazy place these days. How are you guys sort of handling that? And yeah.
Yeah, so we're mostly working remotely due to kind of COVID restrictions. We do have a physical office, which is mostly empty, I guess, but people do come in. Yeah, we have some remote people in the US as well, and we're always hiring interesting talent.
I'm sorry. Yeah, on hiring. I mean, do you guys do internships? What kind of background are you looking for from people?
I think internships are, again, really hard to do remote. I think you're missing a lot of the experience and the immersion and like meeting a lot of people. And so I'm not a huge fan at the current climate, let's call it.
Wow. So watch this space. Okay.
Yeah, yeah, exactly. But definitely interesting. And we're always hiring people who have like ML, PL background, like machine learning, programming languages background. Tabnine works on the intersection of programming languages and machine learning, on representations of code and learning models of code, and doing efficient inference for models of code and stuff like that. We're kind of probably the biggest Rust shop in Israel, and we take a lot of pride in being Rust and Rust enthusiasts, and dealing also with all sorts of low-level inference code using Rust, and also assembly, actually, to be honest.
Yeah, I mean, that's fascinating in itself. I have many questions about Rust and about, this sort of like low latency response time things are very interesting. I think that's an area of growth. Anyways, we can't get into that. We're running along already. So, yeah, how can people try out Tabnine? Like, what are people able to use it? Is it cost an arm and a leg? How does it kind of work?
Yeah, so Tabnine is completely free. If you're like a developer, you can download it now, install it, and use it completely free forever. The free product is very powerful and useful, and we have millions of developers using it in their IDE as we speak. I think it's really, really powerful. The free is almost too powerful, the free version.
Uh-oh. That might
But
be biased, but yeah.
yeah. No, I'm serious, actually. But if you are working in a team, you get exactly to what you said earlier, Patrick, that you would benefit greatly from training a model for your team. And these private models are how Tabnine makes money at the end.
That makes
We
sense.
train private models for teams, and you just connect your repo, and you get a private model delivered completely automatically for your team that knows the kind of the idioms of your team and the vocabulary, the entities and what's going on in your code base, and gives you much better tailored completions for how you do stuff. And you can also customize it to say things like, oh, don't train on that legacy code. We're actually trying to escape that. And
Yeah, sure,
if you
sure.
keep training on it, you get like this
Bad
effect of
habits.
you get the Jupiter level kind of gravity of the legacy code that you can never escape, right?
Yeah, I mean, that's like anytime we point our like code count at, we use protocol buffers and it generates tons of code, and your line of code count is swamped by all this auto-generated code. And I think it used to be, I always thought, oh man, stuff's expensive. These developer tools are expensive. But then now, like starting to think a bit more with a manager hat, I realized actually like programmer time is very expensive, and anything that helps people sort of go faster and not break things and make mistakes. Oh wait, I think I'm misquoting. Anyways, anytime you can sort of help people, in that domain, like it's enormously valuable. And I think people are catching up that like programmer efficiency is a huge bottleneck.
It's a huge bottleneck, and we see, a lot of improvement when using Tabnine. Like users report between 15 to 30% improvement
Oh, wow.
in their productivity. Depending, again, it depends on how, let's call it, mundane part of your coding is, or if you're using very languages that are like contain a lot of boilerplate, and Java comes to mind, for example.
Burn.
Yes. Then it's really really useful. If you're writing like front end code, it's extremely useful. I think in terms of languages, our distribution is kind of JavaScript, Python, and Java. I think maybe are the top three languages of Tab9 users. Yeah, I think it's extremely useful in all languages, but these three see like huge adoption. Also PHP, and I think PHP and Rust. We use it ourselves, obviously, for Rust.
This thing that you kind of alluded to also like intrigues me, because this is again like thinking with manager hat, like it's sort of not talked about, and it's pretty expensive, which is when you bring new people onto the project, even if they know what they're doing, like getting them adapted to the sort of idioms and styles and all of that through code review, takes, probably even more than 1-to-1 number of hours for those new people to write the code, of people to review and correct the code. But it's also frustrating. You battle sort of like, this isn't a personal thing, like egos come in, like it's a very expensive number of hours drain on the team thing to bring new people up. So having a tool that sits alongside of you and sort of like in a low ego risk way sort of encourages you to write conformant code. I mean, to me, this actually is super exciting.
Yeah, it's low ego, and also it's there for you in the sense that you don't reach the code review and get slammed, right? Because you already get something that is the worst case is that you've done the common thing, right? So it lets you really punch above your weight in a sense,
Yeah.
right? Because like, I'm at least as bad as the average. I will not fall below that. And I think actually much better. And an interesting thing that happens with Tab9 is that when you see the suggestion, it also makes you think sometimes. Like when I use Tab9, like I get some suggestion like, but wait, that's not the way I intended to do this. So what am I missing? And actually, it turned out several times that there was just a new API that I didn't know about, right? And people started using, but I'm like, I haven't touched that for a long time. So discovery there, even if you end up not using it, just being aware that this thing has changed is really interesting. And this is also kind of gives you like a picture of what's going on, right? As you're programming things that you would not be aware of otherwise. So that's another aspect of that.
Nice. So in the show notes, we'll have a link to Tab9, to their Twitter handle, to Eran's Twitter handle. If you have any questions or reach out to him, or you want to check out the product, I mean, this is super exciting. I'm going to go try it, even though you didn't name my favorite languages. We're going to go see how this goes and give it a whirl. But I had a very enjoyable time. Thank you for coming on with us.
Thank you so much for having me. I had a lot of fun.
Music by Eric Barndaller.
Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, and adapt the work, but you must provide attribution to Patrick and I.